multithreadings. Both of these are ways to achieve multitasking. Now, what is multitasking? When you are doing multiple tasks at the same time, it is called multitasking. For example, this mom, she's taking care of baby, picking up the phone call, and at the same time cooking food. So she's doing all these multiple things at the same time. That's why she's called to be doing multitasking. Our computer in similar fashion does multiple tasks. For example, on my computer I have PowerPoint running, I have a browser running, I might have calculator, couple of other programs running. So all these different programs are basically different processes, and if you want to see those processes, you can see it here in Windows Task Manager. If you go to Details tab, all these entities which are listed here, they are all different processes. So for example, for Chrome I have all these processes, and for PowerPoint I have this guy here, and there is a PID. PID means process ID, so they have their own different process IDs. So understanding processes is pretty easy. Basically they are different programs running on your computer. Then what is actually multiple threads? Okay, so let me go back to my presentation. So multiple threads basically lives within a same process. So in this diagram here, this outer block is a process which has its own virtual memory or an address space. Now it can create multiple threads inside it. Now the difference between process and thread is that threads will share this address space. Now they will have their own instruction sets. They will be doing, each of these threads will be doing a specific task, and they will be executing their own code. They have their own stack memory, own instruction pointer, but the only thing that they share is the address space, which means if you have any global variables defined in your program, they can be accessed by these threads. Any heap memory can be accessed by these threads. Okay, whereas if you look at the processes, this is process 1 and process 2, they have their own address space. Okay, and if they ever want to communicate with each other, they can use inter-process communication techniques such as a file on the disk or a shared memory or a message pipe. Okay, so from these two pictures you can at least guess what is the key difference between process and a thread. So the key difference is threads are lightweight versus processes are heavyweight. Okay, that's the key difference. Now if threads are lightweight, why do you even care to create a new process? Well, first of all, these processes are different programs written by different companies, so they have to run separately as separate process. And another thing is, if you have any error or a memory leak in one program or one process, it will not impact another process, versus if you have that problem in one thread, then since it is running under, as you see in the diagram, if this thread has a memory leak, then it can potentially impact the entire process, and it can have